Hi guys, welcome back to another video tutorial. So in this tutorial we'll be going over functions and graphs. So this is under the second year of A-level maths, and what I've done here is I'm going to go through two questions or two examples if you like, just to kind of start from the kind of basics so that you guys understand what is happening. And because there's a bit more to this, what I'm going to do is the other things I'm going to put in another video tutorial, just because I don't want to put everything under one and make it too long and make it too boring. So let's get straight to the first question. So the question here is asking us solve the equation modulus 4x minus 1 equals to 3. Now, before doing this, one thing I would kind of, make sure that you guys understand, or say that you guys got to understand, is this modulus sign. So say for example I have modulus 5, right? I don't know, 5, 6, doesn't matter. What modulus basically means is it only wants the positive values, right? So your answer is always going to have to be a positive. It does not want to take any negative values. So the output from a modulus has to be always positive. So modulus of 5 is always just going to be 5. So if I have, for example, modulus of minus 5, again, because the output has to be positive because of this modulus, it's still just going to give me 5. Modulus basically means the absolute value, right? So all it means is whatever input values that you have, whether it be positive or negative, your output value is always going to be positive. So one thing as well, just so I'll write it here so that you guys can see what I'm referring to. When I say input values, I'm referring to my x values, and when I say output value, I'm referring to my y value. So basically your y value always has to be positive when you have modulus. That's it. So y value has to be positive, right? It has to be positive for modulus, right? And then x value could be negative or positive, doesn't matter, but your y is always positive. Now, to solve this question, right, it's giving us an equation and we need to solve it. Now, long story short, what you guys are going to need to do here is you guys have to get or sketch two graphs, right? And you're going to see where those two graphs intersect. And those 2 points where they intersect is basically going to give you the answer to this question. So the first thing that I'm going to do, right, is I'm going to sketch those two graphs. Do you guys know what those two graphs are from this question? One of the graph is going to be y equals the modulus 4x minus 1, right? And then the other graph is going to be y is equals to 3. So those are the two graphs that I'm going to sketch. Now, how I'm going to sketch y is equals to modulus of 4x minus 1. And if you have no idea of how to do it, it's not as hard as it looks. Okay, it's quite simple. But what I'm going to do first is I'm going to sketch y is equals to 4x minus 1. Okay, don't worry about this modular sign. I'll show you how we're going to get to that. But first sketch the just the normal graph for x minus 1, and hopefully everyone or all of you guys watching this should know how to sketch this graph, right? So what you're going to do is you're going to put x equals 0. If you put x equals 0, your y is minus 1. And then if you put y is 0, you're going to get your x value. So that's going to be x equals 1 over 4, right? Remember, when we want to sketch a graph quickly, we just put x equals 0, find your y, and then put y equals 0, find your x. Okay, so I've got my two coordinates. Now also another thing, just be careful, look at the gradient. Obviously if the gradient is positive, you should know that your graph is going to be going this way, and because if there was a minus 4 here, you know your graph is going to be the other way, right? So be very aware of that as well, of the gradient. So if I'm going to draw my graph here, okay, this is not going to be accurate, guys. I'm not using a ruler here, so apologies. Okay, so let's say this is my line, and I'm going to put this as my y-axis, and I'm going to put this as my x-axis. Okay, now if I'm going to sketch this graph, so again, let's put the point. So when x equals 0, y equals minus 1. So okay, minus 1, I'm just going to put it somewhere here. And when x equals a quarter, y is 0. So x equals a quarter, so somewhere here. Okay, so we know, because this is a positive gradient, our graph is going to go through these 2 points in this shape. Okay, it's good enough. Okay, obviously you guys are going to use a ruler when you do it. So this is my graph for y equals 4x minus 1. But the question was asking the modulus of 4x minus 1. Now if you remember our little explanation here, what we were discussing here originally about modulus, what do we say if modulus means? It means our y values have to be positive, right? or y value here in this case, but y values has to be positive. If you look at this graph, obviously, okay, let's say this is 0. From this point to this point, you can see all your y values is negative, right? Can you see that? All your y values is negative. We don't want this. We want this to be positive y values. So what we're going to do is basically we're going to reflect this line along the x-axis. And what that will give us is basically, I'm going to do this way. This is going to give us this. A line like this. And if you can see this dotted green line, can you see now all your y values are positive because everything is above 0? Let me just kind of repeat what I just said there. Because I want the modulus of 4x minus 1, I'm going to take this yellow line and reflect it along the x-axis. So that means I can get all my y values to be positive. And then this is what I get. Y is equals to modulus of 4x minus 1. So I guess really what we should say is this green line, again, I'm not being very accurate here, but this green line is, and this green line and this dotted is our graph for y modulus 4x minus 1. So we don't want this yellow line, basically. You don't need this. Does that make sense? You can see now all your y values is positive because everything is above 0. So whenever you see questions that's asking you to sketch modulus of, I don't know, 3x minus 1 or half x minus 5 or whatever, all you're basically doing is you're getting rid of the negative y values, and you do that by reflecting it on the x-axis, which will give you the positive y values, because this is what we want with modulus, positive. And that's it. That's how you sketch a modulus of y equals 4x minus 1. Now my next graph that I need to sketch is y equals to 3. So y equals to 3, again, I'm not being very accurate here, but it's gonna be obviously somewhere like this, right? So that's gonna be my y equals to 3. Now, can you see in these two, when we drew these two graphs, there's two intersection points? Can you see that? Can you see those two intersection points? Well, there's two intersection points. One is here, so I'm gonna label that as point A, and then the other one is here. And remember what we said at the beginning, right? You're sketching two graphs and you're going to find two intersection points that intersect, and that's going to give you an answer to this question. Basically, these are the two intersection points that you need to find. So if we're going to find this, if we're going to write this now at point A, so let's say point A, let's use red, I guess, because we used A. So at point A, so for point A, right, how are we going to find the coordinate? Okay, now it's quite simple. You can see now this dotted line is the reflected part, right? Which means it's the reflected part of the modulus of 4x minus 1. So when it's the reflected part, what we're going to do is we're going to take our 4x minus 1, which was our graph originally, but we're going to put a minus in front of it. Okay, and then that is going to equals to the graph that it's intersecting, which is 3. And then we're going to solve for x. So if I solve for x, I'm going to have minus 4x plus 1 equals to 3. So minus 4x is equals to 2. So x is equals to minus half. Right? So let me just repeat that. I'm only putting minus when it's on the reflected part of the graph. Right? You don't put minus on anything else. So because the dotted line is the reflected part, we're going to put minus for our 4x minus 1. And then you solve for x. Now for point B, to find my x-axis at point B, if you look at the graph, this is my original y equals 4x minus 1, right? The original. So for the original, we don't need to put minus. We just write 4x minus 1. And then we equate that to, again, the graph that it is intersecting, which is 3. So again, now we just find x now. That is it. So x equals 1. So your two coordinates at point A. So point A, your x value is equals to minus half. And at point B, your x value is equals to 1. And that is your answer for this question, really. That is it. So all you got to kind of understand is, obviously, when you're sketching this graph modulus, you only want the positive y values. And then obviously when you're trying to solve for x, this is why I put dotted line, because dotted line, for me, it just shows it's the reflected aspect. So whenever it hits the reflected part of the graph, you want to put minus in front and then solve for x. But when it's on the original part of the graph, you don't need to put minus, you just put the same thing and you solve for x. Okay, so if there's any doubts on how, any explanation that I've just given in this question, just put it down in the comments and I will help you guys out. Okay. Right, so now if we go to question 2, this question is a bit slightly different in that we have two functions where we need to sketch the graph, and they've given us a range, well, input values for x, so like a limit if you like. Now what we want to do here is you want to take it graph by graph. You're going to sketch, first e to the minus x and then x cubed plus 4 within this limit. Now what I'm going to do is first I'm going to sketch, okay, the e to the, so y equals e to the minus x. Right, now if you're not quite sure on how to sketch this, right, let me again draw the graph. So what we're going to do is quite simple. It's not, again, it's not very difficult. Just take it step by step and you see what we're going to do. So this is going to be y, this is going to be x. Okay, now how does an e to the x graph normally look like? Do you guys know that? E to the x normally, so if I just to quickly put that here, e to the x, is something like this, right? And then obviously that, well, okay, yeah, something like that. But if I'm going to put, so I'm going to use these values, right? If I put 0 in e to the minus x, so let me write y equals e to the minus x. When my x value equals 0, if I put x equals 0 here, what is my y value? So e to the minus 0, what is that? 1, right? So my y is 1. So I know that my e to the x is going to be going through 1, right? Now we know that, okay, e to the x is going to be like this. So let me just draw my original graph. So that's my, no, number e to the x, yeah. So let's, again, this is not accurate. So this is my e to the x, right? And this is obviously at 1. But I want e to the minus x. So let me just write e to the x. I want e to the minus x. And e to the minus x is basically a reflection in the y-axis. So you're going to reflect this on the y-axis. So what you're going to have is you're going to have something like this, right? That keeps going. So that's my y equals e to the minus x, right? Because you're reflecting this in the y-axis. Now be careful. If you look at this, it's giving you a range between -5 and 0. So I know my range here is 0, so that's fine. And -5, again, this is a sketch, so you don't need to be accurate. I'm going to limit this to -5. So that's going to be my graph for e to the x. So basically, if I actually that, let me just draw it this way. So that line is my e to the minus x within the range of -5. Hope that makes sense. Okay, so that is all it is for e to the minus x. So it starts with -5, right, and it ends at 0 because x has to be smaller than 0. So I'm just sketching this. Obviously I'm going to redraw this in a separate graph because I'm going to show you, but I'm just doing this separately. Now the x cubed plus 4, right, x cubed plus 4. So let's just draw that somewhere here. Actually, you know what, we can just rub this bit off. We don't need that bit. Okay, so let's draw x cubed plus 4. Okay, so again, this is going to be y and this is going to be x. Now x cubed plus 4, right, is giving us a range, I mean a value, a limit here as well. From x, it has to be greater than or equals to 0, smaller than or equals to 4. So if I put 0 in here, what would my y value be if I put 0? My y value would be 4. So I know, okay, it's going to start from 4, right? Because it can't be below that. Now, if I put 4 in here, what's my y value going to be? What's 4 cubed? 64 plus 4, 8, so 68. So it's going to be somewhere here. So that's when my x value is 4. So I know, okay, that's at 4 and that's at 0. So I know my graph is going to be something like, whoops, not like that. It's going to be something like a curve, if you like, right? It's not it's not meant to be a straight line. It's meant to be like a curve, right? And why is it a curve? Remember, an x cubed graph, right, always starts on the left hand side. So it could be from the top or it can be from the bottom, but we're coming at the end of the x cubed graph. So this is all we need. We don't need to draw anything else here because of the limit that we have in between here, right? So this is my y equals, if you like, x cubed plus 4 within this range here. Now I'm going to put all of these two graphs together and I'll show you. And there's also something else that I didn't put here. I don't know if you guys noticed. that has to be put as well. And I'm going to draw this in one graph here. So if I just draw this here, and if I draw that here, right? So this is my y, and this is my x. Okay, so let's use the green anyway to show. Now we're going to draw y equals e minus x, so that's going to be the same thing, right? So e to the minus x, that's same thing here. So that's obviously at 1. Now that's at 1, and obviously this is going to be at minus 5. Okay, now you have to draw these dots. I'm not sure if you know about that. You have to draw these dots, right? And these dots are very important because if remember, I don't know if you remember in inequalities, I think we did this was in first year maths as well and GCSE. Remember when you have an equals, you have to shade the dots. Well, here we have an equals, so we have to shade this dot, whereas this one you don't shade. This is just non-shaded because there is no equal sign here. So that is the thing that I did not put in these two graphs that you have to put here. Okay, so you have to shade it when you see equals. So that's for e to the minus x, right? And obviously this is at 1. Now the other one is when this was at 4, wasn't it? So when it's at 4, again, so 4 is going to be somewhere here, obviously above. So let me just draw a circle first, and then our graph is going to go somewhere like this. And obviously the above bit is going to be 68, right? So you could extend it a bit if you like. And I'm going to draw another circle here, and this stops when x is smaller than or equals to 4. So it stops at 4. So if I just put that here, that's 4. Now if we look at this, look, both of them are equals, which means we have to shade both of them. Yeah, again, this is not, I'm not very accurate, but you have to shade both of them. And this was at y equals 4. And this is pretty much how you sketch this g of x graph. Remember, you just got to use these values as your boundaries, right? You start at minus 5. You see, look, I'm starting at minus 5, but then I'm ending at 4. And I'm ending at 4. But it can't go beyond and it can't go below. And then you're just drawing the graph within the range, making sure that obviously you put those x values in here as well, just to see where it will be. Okay, and that's pretty much it. And and obviously make sure that you shade or not shade depending on the inequality sign. Now if we look at question B, right, it's asking us find the value of a such that g of a equals 40. Okay, g of a equals 40. So if I put g of a equals 40, what's my g of x function? We have two functions here, right? We have two g of x functions. So we can do first two things. We can use the e to the minus x, and then we can equate that to 40. Oh, that's not 10, that's 40. We can equate that to 40, right? Because that's one of my functions, g of a. One thing I forgot is, because you see a now, instead of x, you're going to put a. So it's going to be e to the minus a equals to 40. Now, how do we get rid of the ln? Sorry, e. I just said the answer, didn't I? Damn it. Okay. So if you want to get rid of e, you have to do the opposite, which is ln, right? Remember ln? So you have to find ln. So to get rid of the e, now that e goes that side, so now you're going to have ln 40, because that's the opposite of the exponential, right? So if you do ln 40, I'm not sure what ln 40 is. What's ln 40? So you have minus a equals, if you put ln 40 in your calculator, 3.688. So it says to 2dp, right? So 3.69. So 3.69, because obviously you need to get rid of the a or the minus. It'll be minus 3.69. So one of your a values is going to be minus 3.69 for this one. And obviously for the other function that we need to find, which is x cubed plus 4. So now you're going to have, so remember, your g of x equals x cubed plus 4. You want g of a, right, first. So this is how I got the a. So g of a means wherever you see x, you put a. So a cubed plus 4. But then you know what g of a is because they've given you 40. So then you say a cubed plus 4 equals 40. So a cubed is equals to 37. So a equals to cube root of 37. So what's cube root of 37? Which is 3.33, I guess, in two decimal places. A equals 3.33. and that will be your answer for the other function. Okay, so that will be your other value. Okay, so this is pretty much it on how to solve question 2. Again, if you have any questions on this, just put it down in the comments and I will, help you out. And again, if this video tutorial has helped you out, please give this video a big thumbs up. It would really mean a lot. It means that, okay, this is working, and I guess I could just keep putting more tutorials. Any topics that you guys are feeling you're struggling with, just put it down below in the comments, and yeah, I will do them. Until the next time, this will be a wrap.